exactly what we just did. We just want to reproduce the volume, and then I'm going to tell you what we're going to do. So, if we're going to physically measure this on you, there are 4 basic volumes again, and you have a better picture from my handout that came just from the PowerPoint today. We have TV, okay, which stands for tidal volume. And that's the normal amount of air, so the normal inspiration that you're basically using out. So it's like that, about 500 mil. That's TV. If you draw a line from the top of that to this, that's going to be your IRV, which stands for Inspiratory Reserve Volume. How much more you can inspire. That's the second lung volume, IRV. And you sort of have that all in your list. So inspiratory, can't say really well. Okay, inspiratory reserve volume. Okay, tidal volume, IRV. Okay, this one. This is expiratory reserve volume. That's going to be how much more you can expire than a normal breath. That you can blow out more than normal. So ERV. And half the words there. Finally, our 4th volume is, we didn't get all the air out, we have our residual volume. Those are the 4 lung volumes. So we have a tidal volume, our normal breath, how much more we can inspire than normal breath, our inspiratory reserve volume. We have expiratory reserve volume, how much more we can let out than normal. And finally, the residual volume, which we can't control. Those are the 4 lung volumes. Okay. What we care about are capacities. And this is all just directly from both handouts. Capacity is when you add 2 or more of these volumes together. And there's all kinds of capacities. If you kind of look at that, I care about 2. I care about what's called, and what we'll measure, the vital capacity. And that's going to be basically, and we're going to see this. Okay, this whole area here. It's going to be, if we have you inhale what you will, as much as you can, as I kind of demonstrated, and then exhale all that, as much as you can. Those 3 volumes, your inspiratory reserve volume, your tidal volume, your expiratory reserve volume, that represents everything but residual. So vital capacity, just by use terminology, is tidal volume plus inspiratory reserve volume plus expiratory reserve volume. And again, that seems important because that's as much air as you can basically move in and out of your lungs on a given breath. That's your vital capacity. It sounds vital. The only other capacity would be your total lung capacity. Those are the only capacities I want you to know. Total lung capacity. Which is basically all 4. So it's going to be your vital capacity plus your RV. Okay? You can write it that way. Vital capacity plus your residual volume. All 4 volumes. That's the start. Any questions about that? Again, directly from the book, handout, etc. Even I mentioned today that you need to know the 4 lung volumes, and we're going to measure these. And then these 2 capacities, especially this one. Vital capacity is going to be these 3 volumes together because it's representing how much air you can exhale. We're going to do that. Okay, this is ever going to be your subject. You're going to actually determine your tidal volumes, this works, and then actually expire as much as you can. So inhale as much as you can and expire that. We'll be able to measure. That will be your vital capacity.
Why 3? Do you have all 4 volumes? Shouldn't it be all 3? Because your vital capacity is the 3? Or are you adding?
You're adding the residual volume for your total lung capacity. So it's all 4 volumes. Your vital capacity plus your residual volume. Okay, that's fine and dandy. But what we really care about, usually we actually care about your vital capacity. That's going to represent sort of how much you can expand your lungs and get rid of. But we also care about another factor that we're going to measure. So we care about how much you can exhale, but we also care about if we have you do this, how fast can you exhale? Okay? This is going to be called forced expiratory volume, because we're going to basically have you do it as fast as you can. So FEV represents forced, because we're making you do this. Expiratory volume. Expiratory volume. Sort of how fast can you basically exhale? And we sort of measure in seconds. So we want to see how much of your vital capacity, if we say 1.0, how much you got out in that first second. I'm going to sort of give a demonstration. I got two formulas here. So, we're going to measure your vital capacity, how much air you can move, but if you sort of go by time here, 1 second, how much of that did you get out in the first second? And that's sort of the major, and when you look at your lab book, you'll see this. We'll want to see how much you get out in the first second, but really, it's the first second. Okay? And that's going to be your FEV 1.0, as far as percentage. So, to really illustrate this and what you're going to do, there are going to be two formulas you need to know. And that's going to basically, I'm going to put them up here, that's going to help you diagnose one of these two classes, again, notes are on there, of lung diseases. And we're going to show you. So it's going to be either obstructive lung disease, that I'm going to talk about in the notes as well, and or restrictive lung disease.
Yeah.
So to determine that, we can, and we'll be able to do it, we can basically use these factors here. There's two equations we're going to use, okay, to determine whether you have obstructive or restrictive. Hopefully you guys won't have either. First equation, we're going to do your measured vital capacity. And what we actually measure when we have you do this, VC, okay? VC, vital capacity. Make sure, because I don't want to keep writing out vital capacity. Over your predicted. Okay, we can predict, and I'll show you a formula because you are going to predict your particular one. You can basically predict your vital capacity based mainly upon sex, size, and age. So it's an average, but if you're male, usually you have a larger expansion, and your age is sort of decreases, and obviously we're going on your height as well, and so bigger, more lung expansion. And there'll be a formula for that. And so we want to actually determine, okay, we can predict your vital capacity, but let's measure it. And let's see what percentage it is. Okay? So this is going to be, again, times 100. And we're going to see how close you are. How much is your measured vital capacity compared to your predicted. And we're going to show you what that means. So that's the first formula. And for the lab, you're going to actually, there's a formula I'll show you. You're going to actually do your predicted, and you'll obviously be able to do your measure and do your exact quantity. For the test and for those extra problems, I'm going to give you the predicted and you find. But here's the second one. We want to do your FEV 1.0. Okay, how much volume we got in the second, and I'll explain this, over your measured vital capacity. Times 100. I'm going to give some numbers there as examples. Those are going to be the two formulas you need to know. So for today, we're going to actually use them to figure you out, because whoever your person breathing is. But for the test, and I have those on those extra problems, I'll be giving you these values. You're going to have to calculate this, and I'm going to show you how, with that calculation, you can diagnose an obstructive versus restrictive disease. But let's just do some numbers now. Let's just play those in. Let's say that our predicted VC equal 5 meters. Okay? Sorry, I have to just go across. Our measured VC, pick the new buildings, should be. The measured VC equal 4 liters. Okay? Those are two of the values. You got a predicted and measured. Now I've got to say what we got out, when we actually did it. How much of that did we get out in the first second? So our FEV 1.0, just not happy about this. But now I don't know how I'm supposed to do this. FEV 1.0 equals 2.5 meters. Okay? Those are the three values. And again, you're going to get this. You're going to, right now, you're actually going to, do the formula to get your predicted. We're going to measure your vital capacity and measure how much you got out in 1 second. Again, the idea is, your measured vital capacity is, we're going to have you do this as fast as you can. So, you're going to inhale as much as you can, and then blow it out as fast as you can. So then we can measure top to bottom. That will be your vital capacity, your measured. And then we'll do the timing of that and seeing, how much in that first second did you get out? 60%, 70%, 80%? How much of your vital capacity did you exhale in that first second? And if we just do the numbers here, I really wish I just had a normal piece of chalk. But my wish is not going to be granted. Okay. So let's do this one. If we're doing our measured versus predicted, okay, our measured BC was what?
4 liters.
Okay, our predicted? 80%. Now I'm going to give you, by the way, values which are abnormal or bad. And usually it's going to be something like, if you have under 70%, but I might give you a different one, but whatever I give you, it's sort of, you've got a problem. And we'll show you what problems you might have. Because I'll do that next. But everyone sort of get how to do it. Okay? You're going to actually do your predicted, do your measured, put it over it, see how close you are to having your lung expansion so you can do this. Now, here's the second one. So we want to see, okay, we see you've got 4 liters out. That was what your measured BC is. And you got 2.5 liters in the first second. So to do this one, again, we have 2.5 liters. And remember, some people, they always confuse that and put the predicted, but it's not. It's the measure, 4 liters times 100, and that should be like 60%. If I've done that right. Okay? Now, those are the 2 calculations. Here is how we're going to define, with that data, those 2 calculations, whether you have an obstructive or restrictive lung disease. So let's do obstructive first. When you're thinking obstructive, okay, you're thinking things like COPD, chronic obstructive pulmonary disease, asthma. You can have allergic reaction. And I'll show you, you're obstructing expiration. So, I'm running out of room here, but if we sort of take the idea of we have these bronchioles, and here's the alveoli, and if you have an obstructive lung disease, basically, if you ask the person, in general, let's say you have asthma, and we give you time, and we say, okay, breathe in as much as you can, expand your lungs, your thoracic cavity as much as you can. Okay, maybe you'd be sore. But should there be a problem? Okay, would there be a problem on just the ability to expand your lungs? No. No. Okay? It's going through a smaller opening, but your diaphragm will contract fine, you can change the volume fine. Again, it might not be as fast, but you should be able to inhale, and if we ask you, okay, just take your time, but blow it all out, again, your diaphragm, you can do it. Your vital capacity should be normal. And so, but what you're obstructing is, if we say now, can you get it in, blow it out as fast as you can, through that small opening, are you going to be able to do it as fast? Does anyone actually have asthma or been tested? So you sort of know these tests, right? You've actually had it. And so, in that case, the idea is we can use these 2 terms. So we could basically say, and I'm just going to say, for these BC, this is sort of the top formula, and FEV 1.0 percentage. I'm going to write it for both here. So again, if you have an obstructive lung disease, your vital capacity should be what? Normal or abnormal? Normal. Your vital capacity, well, we're just starting this, okay? Our vital capacity, again, is just our ability to expand our lungs, okay? And, we can do it, it might be slow. So we expect a normal vital capacity, but how about your FEV 1.0 percentage? How much you get out of that per second? Not so good, right? Because you can't blow it all out as fast. So you're going to have a below normal FEV 1.0, which is the second formula. So you fill this in, and now it's over to the lab, and then you have practice doing this. Restrictive lung disease, you are restricting inspiration. So you could talk about, like we'll put fibrosis up here, but if you have a neuromuscular problem where your diaphragm isn't working as much, and it won't go down as much, you're going to restrict your ability to expand your lungs. If you have a fibrosis of the lung tissue, so it doesn't have that elasticity, you're not going to be able to expand your lungs as much. And so if we ask someone with a restrictive lung disease to basically inhale as much as they can, let's figure their vital capacity, are they going to be able to get as much in? So vital capacity will be compromised. But if we say, okay, that's what you got in, now blow it out as fast as you can, there's no obstruction, that should be fine. So your FEV 1.0 of this should be okay. Now this is ideal. Okay? In real life, of course, things will start blending together as far as real symptomology. But we're not in real life here. I don't like real life. So the idea is, for a restrictive inspiration, we expect a below normal vital capacity. Again, I'll give you the value, and I'll probably give you 70%. But we expect a normal ability to put in FEV 1.0%. They're exactly the opposite. I'm either going to give you normal or this or this. I'm not going to give you they have both, okay, where they're both under 70%. That's not going to do it. So if you're doing a problem and you get that, either you made a mistake or I made a mistake. But I've gone through a couple rounds of checking, so probably it's something you're doing. The biggest mistake people make is this. They'll put your FEV1 over your predicted instead of measured, okay? Obviously that's a big difference. So what does this person have? Because vital capacity, that's what this is. It's saying it's 80% of what it's predicted. It's within normal range, because again, I'm giving below 70. But how much of that measure we got on the first second? 60%. This person has an obstructive lung disease. That's the problem. Okay? So as far as, and again, you'll see all my extra problems that I have in the back there. I've got the answers online. If not, I'm putting them online. You're going to have a couple of those Boyle's Law, Dalton's Law ones. P1, B1, that kind of stuff. And then you're going to have this, okay? And again, it'll be, I'll give you the volumes, I'll give you the predicted, and the FEV. You do those calculations, and you tell me which one it is.
Would 100% of both of those be normal?
You don't have to be 100%.
Just
100% would be really good. Basically, and we'll see for us, basically over, sometimes it's 80, but over 70% of either is fine. It's pretty normal range. Now, when it comes down to it, you might actually find that this is over 100% because predicted is just based upon averages, right? You might have more lung capacity than what's by genetics, et cetera, than it shows. So this can actually be over 100%. That's obviously really good. This can't be, because this is saying how much of what we measured did you get on the first second. And again, 70% or more is fine. Okay? Now, let's do the lab. So to do the lab, I'm gonna show you the calculation is in the 2 pages back before you predicted. In fact, maybe I'll show that now. If you have to go back to the pulmonary function 1 lab, which is right before this, because we're not really doing that. And page, let me find it. I hopefully do the same page. Or, wait a second, I gave you the formula, right?
Yeah.
Okay, because I put it on the sheet, so it's on the, the bottom of the first page, okay, the bottom of the first page has because I know that book, I think they took it out. Have for, again, it's whether you're male or female, you put your height in centimeters, I kind of gave you, got to convert it to inches first, multiply it by 2.54 centimeters per inch. So you multiply by that and subtract again those numbers times what your age are and then minus that number. And it should be in liters. So it should be between, I'm pretty sure it's in liters. Yeah. So it's going to be like, 3.4 or 4.1 or something like that liters. That's going to be your predicted. So you do that. Okay? So now we can actually do it. So let's show you how we're going to measure it. We're on pulmonary function 2. And you go to the setup pages. What you're going to need for this is your usual BioPack things, your bottom drawers to hook up, and then the 2 drawers above it. Which is going to be this puppy, and finally, this thing's cool, guys. The ones that aren't broken. Calibration syringe. I'm waiting all semester to use this. Okay? Now the idea of this will be the following, and I'm going to kind of go walk us through quickly. First of all, on this has an inlet and outlet. We want to make sure we put the right things on the inlet. And what you're going to do is, you're going to calibrate. I hope this is going to still fit on this, because these are sort of new ones. I'm going to show you how to calibrate once I get this on. Actually, I think you are going to put out a filter first. Usually they come with filters. So some of the bags also have a calibration syringe filter already on. If it does, if you have a bag with that, keep it. So because we don't want to have to keep. These are expensive. The ones you're going to use to breathe, you won't have to. So to calibrate it, you're going to end up, and I'll show you how to calibrate it. You put the syringe on. Everything's going to be on the inlet side, and then this. I'm going to show you how to calibrate it. After it's calibrated, you're going to use your own special sterilized one of these to put on, and your own mouthpiece. Okay, so all these are sterilized, and you're going to be blowing in and doing the breaths. So here's the key. So those are the parts. You go to the calibration. Go to the calibration page next. Okay. If you don't have a book, get something. Look around where the book is, so you're sort of making sure you sort of see it. So let me hook up. So is everybody semi-looking at the book? Okay, you're looking at the book. You're not looking at the book, you're pretending you are. Go ahead over there, you can walk now. I see. Okay. So look, to calibrate, everybody pay attention, okay, even for this. This is sort of important or else nothing works, because this is sort of the trick. Again, to calibrate, you're going to hook the filter up. Okay, if there's one in the bag, you use that, otherwise take one. And then this calibration syringe, and you might have a different sort of setting on this. And the idea of this is, first of all, it's going to tell you just have it on ground and press calibrate, like it does a flat line for 8 seconds. Okay, then on the next page, what you have to do, we've got to try to tell this, airflow is going to be like, sort of measured electrically, and we need to convert that to volume, and this has to give it volume. So to do it, we have to do the following. We have to do sort of these steady, quick strokes of about 5, of strokes, with sort of a second between. Hold it like this because we don't want to break it, right? And have it out, and basically it's going to be. And what you want to see is when you look at these peaks, you want to see sort of this equal up and down, okay? If you have one and then it's not as much, it's not going to work. And it sucks because we're not doing that much, and I want to get real numbers. And if you, all of a sudden, my vital capacity is 72 liters, I'm like, no, not really. Okay? It's because this didn't work. And so what people have a problem with the most, okay, is they don't show as much love coming out as they do going in. Okay? So going in like this, and then they're like kind of, oh, like this, that won't work. Okay? You've got to be. Okay? And you'll see peaks like this. Okay? You want it looking like that. And so you can take, again, in between, you can take a little time, so it doesn't have to be as fast as you can. But the thing is, if you sort of hesitate or something, you're not going to have a good one, and just recalibrate. If you don't do it, it's just silly, okay? Because then what's the point? They have these weird numbers. Let's go ahead and get the numbers. So if you need help, I got a lot of practice doing this, okay? You have to learn the lab, okay? But everyone can have fun, okay? Don't read anything into this, okay? So then, you have that done. You turn to the next page. Literally what you're going to do then, because we're not even going to do the last part of maximum voluntary ventilation, which you breathe in and out for a minute, because again, I don't like to waste our time. I want to get this because it relates. Then you literally hook up, okay, you take this off. Again, probably you're going to have your own syringe then. You use this. You can use a nose clip if you want. They're over there. You're going to have the person, and all we need to do is the following. Okay, don't even read all the instructions because they want us to do this and then that. You're going to do a couple of normal breaths so you actually show your tidal volume, okay? And we're going to end up measuring that, and you're going to turn that in. You see the sheet. Then you want to have the person inhale as much as they can. Hold it for just a tiny bit because we're going to want to measure exactly when it starts coming down. If it's like this, it's sort of hard. I mean, if it's like that. But if you sort of have it where they hold it for a second and you then do it, when we measure, we'll be able to do it. And the key with this is, because you can repeat it, the first time maybe they're hesitant, you need to basically go as fast as you can. So you're inhaling as much as you can, and then boom. Fast as you can, inhale it out. And then the only one thing, well, it'll be okay. I mean, we're going to actually take it for 3 seconds to do the math thing. But you want to try to get out as much as you can in the first second. So much as you can in the first second, and then sort of just keep it going a little bit more. Okay? So when we do that, again, you're going to see a peak. You're going to see something like this. Then here's the key.
You breathe more often.
Yeah, but we won't even care about that. Okay? And again, if you turn to the next page, this will be the key to do this. Okay, so you're on page 8 of the lab. And everybody see at the top. To actually do this, you actually are going to, basically highlight the area. They want you to highlight 3 seconds from basically right where you start here over to 3 seconds. And you're going to press this button that says FEV, and it's going to convert it to the one on the bottom, which will be this. Okay? And this is going to be volume, and this is going to be time. And this will be in liters now. Let's say that's 4 liters. Okay? Now, don't do anything else. Okay? They want you to save it and then do something else, in which we breathe in and out as fast as you can to see how much air we can move in like a minute. We're not even going to do that part. We're going to just analyze this. And to analyze this, you simply are going to use your normal tools. And if you use your, except we're going to use what? PHP. Let me make sure on this. So you'll see this up here when you actually have it. PHP will measure top to bottom. So if you highlight the whole region here, that's going to be your vital capacity. Okay? Then down here is time. So if you just highlight to 1 second, okay, you have delta T, and see that volume, that's going to give how much of that you got in the first second. Okay? So like this whole thing is basically 3 seconds, and that might be, this whole thing might be 4 liters. But if we just take 1 second over, this might be 3.5 liters. And then 3.5 over 4, you'll actually figure that. So these are the 2 values you're going to get. You're going to use that formula to do predicted. You're going to highlight this whole region here for your measured vital capacity, and then figure out how much of that in 1 second. That will be your FEV 1.0. That's what you do. So and that's really what I want you to do. You're not going to do the next part of doing maximum voluntary ventilation. So you're going to do that. Yeah, that's it. That's it. And then you can start working on those problems, or you can go, but then again, I'm here to help. Anything we did today, any of this, if you want more work on this, if you want to utilize me as much as possible, this was right after the test, but otherwise, get all that stuff.
I got that.
Yeah. That one, or really on a sheet of paper, probably keep it because I want you to do that. Yeah. Again, you're gonna just turn that data in with those 2 formulas on a separate piece of paper with your names. Keep that so you can work on the respiratory problem.